Our next presenter is Omar Muriawad. He's from Saudi Arabia. He's the Senior Director of Product and Innovation at General Electric Gas Power. I want to take 10 seconds to introduce him, and then Omar, you can come on screen and share your deck and take over. So Omar is an experienced supply chain leader in the aviation, construction management, and energy industries with exposure to North America, Middle East, and Asian market. Omar has an abiding passion for innovation and delivering cutting-edge software solutions by leveraging lean and agile methodologies to deliver the greatest impact to our customers. And as you can see in his background, he's going to talk about cloud-based composable execution system. So Omar, the stage is yours.
Awesome. Thank you for the intro, Manik. All right. Thank you, everybody, for taking the time. And hopefully you got some stamina left after an hour and a half of good stuff and good presentations. Today, I'm going to speak to you about cloud-based composable execution systems. We'll get more into what that is. But before I start, I'll just give a quick intro. So I'm the product leader at General Electric Gas Power for our manufacturing digital transformation. So what we do is build digital transformation and digital solutions to enable our business transformation for our factories across General Electric Gas Power. So gas power, just maybe a quick intro on what the business is. Gas power is one of the portfolio businesses of GE Vernova. GE Vernova is part of the General Electric portfolio, and it's the portfolio of energy businesses. So basically, about a third of the world's electricity today is generated with GE Vernova's installed base. And about what our main challenge today is as a business is to continue to electrify the world while decarbonizing it. About more than 50% increase over the next 2 decades is expected in electricity generation. And we heard about a few of the automotive presentations earlier, and with everything related to electric vehicles and everything else. So there's going to be a huge demand for electricity coming up. But the challenge is we also want to make sure we continue to decarbonize the world. This is just a quick intro of gas power as a business. Just move to the next. All right. So what you're looking at here today, so I'm really going to be talking about, I'm going to touch on this slide, not to get into too much details over here. This is the ISA 95. This is basically the international standards from the International Society of Automation for the integration of enterprise and control systems. What you see as we go from the left to the right, so the common theme here is our ability as we move from left to right is basically we earn the ability to interoperate over what we call the loosely coupled microservices, the based on event-driven integrations between systems and devices. Devices could be machines, cameras, anything that we operate on the shop floor, and systems could be ERPs, PLMs, traditional execution systems. What you see on the right as well is on the most right of where we are today is I mentioned here a point which is PBC, which is packaged business capabilities. So this is a term I'm referencing Gartner for, which is I'm going to interchangeably refer to it as either packaged business capabilities or loosely coupled microservices throughout my session today. Our key here is for us to basically be shifting from siloed applications to one ecosystem that operates seamlessly together, from process data to data-driven processes. There is a very big differentiator here, and we'll talk more about this later. And from deterministic processes to predictive and prescriptive processes. So even though we have integrations with PLM, with the ERP, which are monolith, as you see here on the right side of the slide, we're continuously finding ways for our end users to not interact with these monoliths. we are basically, for lack of a better term, demoting all of these monolithic applications to the back office. This is absolutely key for us to remain resilient in the face of this consistent disruption and consistent priorities changing as a business. And for us to be more responsive to these changing priorities, moving to the right where we are today was really not an option. It's a must. It's a key enabler for us to survive as a business. And this is really not theory. This is real. It's hard. It's doable though. And we're currently going through it and continuing to go through it. This is basically the vision, our manufacturing ecosystem vision. It's really as simple as this sentence. We want to treat our operators on the shop floor, people who run the machines, people who basically, the most important persona we have, we want to treat them like surgeons with 100% of their focus on value-added work. What does that mean? That means that we want to make sure that our operators are fully focused not on interacting with systems, because if you ask any customer, interaction with systems is a non-value added work. You're not changing the form, fit, or function of the part, which means as a customer, why am I paying you to spend time logging into systems? Which means our operators are required to really focus on three things: performing their standard work, identifying abnormalities, and participate in continuous improvement. It's one thing to really note is that our manufacturing ecosystem principles are heavily rooted in lean manufacturing principles and human-centric design. And what you see on the right side of the slide is basically the 5S key principle of lean. And what we've basically taken that, and what we're showing here is what does that look like from a digital transformation in the manufacturing space, and how are we really approaching the design and the development of all of our digital solutions, and all at the core of it being we want to minimize and, if possible, eliminate the human interaction with the system. That doesn't mean those systems are disappearing, because they're fundamental for us to run the business, but we want to minimize the interaction. And really the vision manifests in the philosophy that I just talked about to eliminate this interaction with the systems. To the next slide. What we're looking at here is what we call the loosely coupled microservices, which is basically the term packaged business capabilities comes from Gartner, which is really exactly what the microservice is in the form of how we're basically think about it. This is what enables us to really say death to the monoliths, no more monolithic applications. And the way to think about it is similar to how you have cloud implementations. The analogy here is with the cloud, you basically pay for what you need. In this case, we basically build these capabilities and we deploy what is really truly needed to drive the required business outcomes in our factories. Every factory has different needs and different requirements, and every line in that factory has different needs and requirements. And this is what kind of this ability, and this enables us to build one capability, scale it out in every factory and every line, and basically take all of these capabilities and scale them out on a specific line as and if needed. In Lean, we basically have the concept of right sizing and equipment. And that Lean analogy really comes, right sizing equipment is right sizing our software capabilities. And this is really key for us as we're talking to our business partners, our Lean leaders in the business. From an IT perspective, you need to remember General Electric is not a cloud, it's not a digitally native business. It's a 120 plus years of a business. So kind of the mindset was not really a digitally native mindset. So in order for us to really engage and have the team and the business speak the language of cloud, we really needed to make sure that we speak the language of lean and bridge the gap between the two. With this kind of configuration, what really the end outcome is that we have infinitely configurable capabilities, and a deployment of such a capability really becomes as simple as master data and training and change management. It's all about configuration and no customization, or very, very minimal customization. These are all, this is just a sample of the many different package business capabilities we have built, and they're all standalone and they're all independently deployable. So this is key to avoid that hard coupling between these capabilities. And not to mention, from a packaged business capabilities, that really drives home our ability to, it speeds up our development process. It has many, many different benefits, but our ability to speed up development process, reduce the overall cost of development, simplify our maintainability and scalability of these applications, among many other benefits. And the reason I'm touching on here the package business capabilities is because this is how we are reimagining what a typical MES system is, a manufacturing execution system, and really breaking it down into these composable capabilities. I'm going to be spending the next 5-10 minutes really walking you through how we've really done it, how we've really taken our packaged business capabilities and the concept of the industrial data fabric and took it forward I'm just going to be taking one of those use cases that you've seen in the packaged business capability and how it really goes through the whole cycle end to end. Now, just maybe a couple of minutes on the use case itself. So we basically build and service gas turbines. And gas turbines are huge beasts of machines that produce electricity. And they go anywhere from 200 megawatts to 600 megawatts of energy generation. They are complex machines. And what we do when we service these machines, we either service them on site at the customer site, or we take the parts out and we service them in our factories. So in this case, you're basically looking at a partial section of what a gas turbine looks like. And this is here, this has comes like a full ring with 92 parts installed that run in the unit at a very fast RPM. So when these parts come out of the unit, we service them, we repair them, we put them back, we need to install them back into the unit. Because these are rotating parts, there's got to be a balance. So it's similar to how you think of your cars. When you don't do your wheel balancing, you're going to get some vibration as you're driving. Similarly, we get very high vibration in these units if these parts are not properly installed in the right location. So this is a very key, and this really drives a lot of loss to our customers, who are the utilities, who are the power generating businesses, and really lost days of generation of power is equivalent to millions and millions of dollars. So installing these incorrectly and having to take them off is not something we can afford, neither does our customers can afford. So what we've really done is, in order for us to really take those turbine blades, the process we go through is called the moment weighing process. So we basically weigh every single blade we have, and we basically take that weight, and we have legacy machines that calculate the moment weight of those parts. And we basically have customization, optimization algorithms in those machines from OEMs that basically tell us what part needs to go in what location in that ring to avoid any vibration. So to balance the weight between the top and the bottom, to basically balance the opposing ends of a wheel. So now that you have a bit more context on the use case, The industrial data fabric, I'm touching here on the industrial data fabric, which is was announced by AWS just very recently at Hanover a few weeks ago. And we basically, what we've been doing is we are taking those design principles of the industrial data fabric and implementing them for all of these packaged business capabilities that we talked about. These packaged business capabilities sit in the cloud, but in order for these packaged business capabilities to work, the input into them is data coming from machines or devices. So the way we work is, and the way to read this is from bottom to top. The first thing we need to do is we basically need to ingest the data. Our machines, such as in this case, we measure the turbine blade weights and the moment weights, and they're basically held hostage in these machines. So first thing we need to do is to go into these HMIs and pull this data out. Now the challenge comes in that we have legacy HMIs, we have every plant has a very different type of machine that does the same capability, and we don't have a very standard way of really pulling the data from these machines. So the first thing we do is, in order to ingest the data, along with AWS, we started building our data acquisition pipeline, which we call iDAP, to ingest this as an example. Among many other examples, I'm just going to focus on this use case, to really ingest this weights and moment weights, which come from in different formats and come in very different from legacy HMIs, from the machines up to the cloud. Now, as we ingest these, the next thing we need to do is we need to contextualize them. So what does contextualization mean? In order to contextualize, that means we need to basically standardize and harmonize this data, because that data needs to be used. And honestly, exchanging of data and ingesting data, which is the typical way of how many organizations have been doing it, is just collecting data for the sake of collecting data, and ingesting this data without context is honestly useless, because you're really missing on most of the opportunity. So that's where the contextualization piece comes in, and it's enriched with data coming from the packaged business capabilities, from the ERP, basically all the transactional data. So that way we give it meaning, we give the data meaning and context. The next thing is, after you contextualize it, you need to store it somewhere. So that's where we would use DynamoDB to access all the data of from the moment weight machines, regardless of where they are, regardless of what type of machine that's coming from, and regardless of what use case this is going to be used for. And this is where the next step is, we need to act on it. And the acting on it is, now that I've taken this data from my machine, I've contextualized it, I've stored it, now I can start acting on it in many different ways. And this is where we have, you see on the top, our different use cases that use the same set of data, but the key here is it can be consumed for different use cases. One use case is, for example, I take those moment weights that are already calculated by these machines, and I would basically develop a standard chart. The chart is what is used by our on-site and field engineers. They take this chart and they install these turbine blades in the order that they're instructed to. We've lost a lot of money by incorrectly sometimes installing these. So standardizing this across all of our fleet, and regardless of where this is coming from globally, was a huge quality improvement for the business. In other use cases, for example, you get a case where one of the parts gets scrapped. For example, somebody is lifting it, it falls, it could break, or it could basically just not be usable anymore, not be in a form or shape to be used in the machine. So that means we need to replace it. And in order for us to replace one, we need to make sure that the replacement part has a weight that aligns with the arrangement that we already have, which means right now we need to rechart and re-optimize. So right now we can use basically the same set of data and now consume another microservice or another packaged business capability. Another one is, for example, in some cases we have given the fact that we have non-standard machines and we have basically, we have different OEMs across all of our plants. Now that we want to decide to optimize how we install these parts, we have another packaged business capability that's focused on that optimization of what part needs to go where. So this is another use case. But the key here is that all of them are basically consuming the same data set, but multiple use cases. And now further back after the act, you have the further enriching of this data. And this is where you close the loop. Is, for example, if I did replace one of those turbine blades on site and I rechart the moment weight, then I now further enrich this data to say this part was now initially charted with this set, and now it's charted with another set. So now I have a full record, part of our life cycle management of a part from cradle to grave, that we're logging and further contextualizing and storing in the same sensor repository. And this is really how we've taken the industrial data fabric design principles of ingest, contextualize, store, act, and enrich with further contextualization. All of this with AWS capabilities in the cloud. And a key part of this was really for us to start with the packaged business capabilities first and start pulling this data, working backward, basically from right to left, to earn the right to really talk about this kind of pipeline of data ingestion. And with that, my presentation comes to an end.
Thank you, Omar. I think I can feel free to come off mute if you guys have any questions. Omar, while we wait for the questions, I have a couple of questions for you, if that's okay.
Of course.
Okay, I don't think I'm sharing the right screen. But what is the journey for a company or a big organization would look like who is trying to get into the ISA 95 standard, which you shared, especially anybody wanting to iterate faster?
What's the journey to get there?
Yes. Yep.
I think it really starts, Manik, with addressing the fact that, because when we started this journey, we didn't start it long ago. We started actually with the AWS prototyping team. We said, hey, listen, we have this specific problem and we really want to address it with a purpose-built capability. We don't want to add this capability or functionality into another monolith that gives us a hard time to, even when we want to use this functionality, that monolith is down because of maintenance, that monolith is down because of X. We just want to have one specific use case. And that's where we started the journey. We took that one single problem and we built our first microservice, our first packaged business capability, to really show us and show our business counterparts what's the art of the possible when you go down that path. And once we started doing that, then all of what I showed, among many other packaged business capabilities, we really just started getting that machine going. And then we realized, you know what, you can actually go from ideation. That was the initial microservice that we did. You can go from ideation to a fully running solution in a couple of months, which was really unheard of in the world of really execution systems or manufacturing or any digital solutions. So for us, that was like a light bulb And then we just went down that path. And then we started thinking, hey, we want to further simplify it, because at the end of the day, it goes back, it's heavily rooted in our vision, which is minimizing to eliminating interaction of the operator with the system. So in order now for the operator to use this capability, we want to make sure that this data is being fed and consumed by this capability without the operator having to take this data from somewhere and manually upload it and do the manual interactions. So this is kind of how we started moving down that path. But it all started with, don't start big, take one business problem and really build a independently deployable, loosely coupled microservice that can address a specific problem.
Nice. Okay. Looks like we have a question from Matt Meyer. Matt, would you like to come off mute and ask your question directly?
Actually, I think you just answered it. So it was more along the lines of, is this part of your larger strategy to move towards industrial data fabric, or are these just specialized use cases at this point? And I think you answered that.
No, it's really moving across everything. When I showed the slide with the purpose-built capabilities, Matt, I just took one example, but really this goes down to every single kind of business capability that we're building right now. Part of our design is thinking, how do we get there? We're not going to be able to do all of this for every single capability from day one, but it's now part of the thinking of we're not thinking how to integrate systems or applications in the cloud. We're now thinking, how do you really integrate? How does everything go from the machine, from the device? It could be a sensor, it could be a CMM machine, it could be a camera, whatever it is. And how does this data flow through that ingestion pipeline, get contextualized and get consumed, with keeping in mind that when we're building these, we're always thinking of what are all the use cases that we'll eventually need. We're not necessarily building all the capabilities for all the use cases from day one, but we're designing and planning for it in order to standardize and harmonize the data set to be consumable by all of these capabilities as and when they're ready.
Are there any specific areas where you're focusing on applying these new use cases? What is your prioritization as far as application?
It really comes down to we have so basically in gas power, we're now well down our lean transformation journey, and basically building all of these lean lines in our factories. Lean lines focus on material flow, but in order for us to really align with the lean lines, you have to also focus on your information flow along these lines, which means anything that disrupts our information flow and not have it aligned with the material flow, which means, in other words, if you're into lean, if you're not meeting, that does not enable us to meet our takt cycle time, which is our throughput by workstation, then that's something we need to really address. So this is kind of how we're addressing the key flow stoppers on our lean lines. This is how we prioritize which capabilities we build. What are the processes that are mostly impacting SQDC? So for us, safety, quality, delivery, and cost. And we go down in that order to really prioritize which capability we're going to work on.
Got it. Thank you very much.
Thank you.
Awesome. Thanks, Matt. Anyone else? The last call for questions. Looks Zeba has a question. Would you like to come on mute as well?
I have a hard time reading the...
Okay, I can try. Omar, your presentation left me with a better understanding of how ISA 95 can help to streamline operations, reduce cost, and improve efficiency in the manufacturing industry. I look forward to exploring this standard further and learning more about its potential application. Nice.
Absolutely.
We can make that connection.